Today we're talking about a new formula for area of a triangle as well as the law of sines, which is helpful because it allows us to use the sine function in any triangle, not just in a right triangle. So first off, the new formula for area here is 1/2 BC sine A, or 1/2 AC sine B, or 1/2 AB sine C. Okay? Our usual formula for area of a triangle like this. Area is 1/2 times the base times the height. That's the formula for area of a triangle that we should all be very comfortable with. But this height h creates a right triangle here. And in that right triangle, we can say the sine of angle A is opposite over hypotenuse, meaning h is going to be c sine of A. If h is c sine of A there, then in our area formula over here, we can plug that in for h, 1/2 times b times c sine of A, which, because of associativity, we can just remove the parentheses. We get 1/2 bc sine A, which is this first part here. And you could show similarly how the other ones come out. So the basic idea here is you can use any two sides you want, B and C, A and C, or A and B. But whichever two sides you're using, it's going to be 1/2 times the product of those side lengths times the sine of the included angle. And what I mean by included angle, if I use sides A and B, I'm using these two sides right here. The included angle is the one between them, this angle, so sine C. If I use sides A and C, these two sides here, then it's 1/2 times the length of A times the length of C times the sine of the included angle B. Similar idea for sides B and C with the sine of angle A. After that formula for area of a triangle, we get another formula which is the law of sines. All the law of sines states, up in the box we have the formula, but I'm going to write it again. The idea is it'll work in either of these triangles. So like I said before, it does not have to be a right triangle. The law of sines will work over here as well. And the idea is just the ratio of the sine of an angle and its opposite side is going to be the same throughout the entire triangle. Like this. So the sine of angle A divided by the length of side A. So the sine of the angle divided by its opposite side length. That ratio is going to be the same no matter which angle you use. So sine of A over A, sine of B over B, sine of C over C, those should all be equal.
Is this for?
And that works for any triangle whatsoever, ever, any type of triangle. So all we've really done at this point is we've looked at a formula for area of a triangle, and we've looked at this formula for the law of sines. That's it. Now let's start using them. Here, what is the area of triangle TUV to the nearest tenth of a square centimeter? Using our fun new formula for area of a triangle, this is 1/2 times 11.2 times 9.2 times the sine of 73. When you plug this into the calculator, making sure you're in degree mode, not radian mode, you should get 49.3 centimeters squared because it's an area. In triangle MNP, the measure of angle M is 25 degrees, the measure of angle N is 61 degrees, and MP is 3.8 meters. What is MN? Here, the nicest thing to know about a problem like this is you can draw your triangle however the hell you would like. M, N, P. The measure of angle M is 25 degrees, the measure of angle N is 61 degrees, and MP is 3.8 meters. So even though the way I've drawn this angle looks like it might be 61 degrees, but this angle certainly doesn't appear to be 25 degrees. But that doesn't matter. I can draw it however I'd like. It's like on the ACT when they say not all pictures are drawn to scale. This picture is not drawn to scale, but as long as you mark the degree measures appropriately, you're going to be fine. In this question, they're looking for side MN. This is what we want. How do we set up to solve for that missing side length using the law of sines? We say sine of 61 over 3.8 equals, it's going to be the sine of this angle over MN. So what is this angle? We know these two. What is this one? 4. So this angle we have to find out is 94 degrees. So this is the sine of 94 degrees over MN. How do we solve this? Cross multiply. We get MN sine 61 is 3.8 sine 94. Divide each side by sine 61. We get MN is 3.8 sine 94 over sine 61, which is what? Should be 4.3 meters. So you could get a problem like this where it asks you to solve for the entire triangle, in which case you'd have to use law of sines again to get the length of side NP. But they didn't ask for that, so don't waste your time doing it. Just get the length of side MN, you're done.
Could you have used...
In a problem like this, again, the best place to start is to draw a picture. Just going to draw mine like this. It is triangle KLM. We know side K is 4.5 yards. Side M is 10.1 yards. And the measure of angle K is 101 degrees. No, measure of angle M is 101 degrees. And we want to know the measure of angle K. How do we set this up? We just say the sine of 101 over 10.1 is the sine of whatever angle K is over 4.5. So now you could cross multiply, or we could realize that we could just multiply each side by 4.5. So we get 4.5 sine 101 over 10.1 is the sine of angle K. At which point we know we have to utilize what? So at this point we know the measure of angle K is going to be the inverse sine of 4.5 sine 101 over 10.1. And they ask for it rounded to the nearest degree, which is what? 26 degrees. So, they asked for the measure of angle K. We gave them the measure of angle K. We're finished. We could go on and find the measure of angle L and the length of side L, but they don't ask for it, so we're not going to waste our effort.
Scratching at the cells of my brain.
So we know that they are 2 miles apart. The spotter in the eastern spot, so he's here, sees a bear 62 degrees north of west. What does that mean? He's in the eastern spot, looking west. His gaze would rotate 62 degrees. So like this. The guy in the western spot sees the bear 48 degrees north of east. So if he's looking east, his gaze rotates 48 degrees, like this. So that is the triangle that we want. We need to figure out the distance that the bear is from each observer, x and y. In order to figure that out, we need to know what this angle is. What is it?
What angle? 970.
70. Let's solve for x first. It really doesn't matter which one we solve for first, but we're going to go with x.
God, thanks.
So we get sine of 70 over 2 is sine of 48 over x. Now we could also have said sine of 70 over 2 is sine of 62 over y. Either way, doesn't matter. We're going to need to solve both of those equations though. So x over here is going to be 2 sine 48 over sine 70. Y over here is going to be 2 sine 62 over sine 70. So plug those each in the calculator, see what you get. X is going to be about 1.6 miles. Y is going to be about 1.9 miles. So, how far is the bear from each spotter? 1.6 miles from the spotter in the east, 1.9 miles from the spotter in the west. Done and done. The ambiguous case comes in if you are given the measure of angle A, the length of side B, and the length of side A, which is going to be the side going from here down around here. So we have no idea how long this side is. It can be as long as we need it to be or as short. The problem is that what's going to happen is in some situations there could be 0 triangles possible. In some situations there could be 1 triangle possible. And in some situations there could be 2 triangles possible.
Never infinite triangles possible.
Correct. Never infinite triangles possible. So, first thing, just as a starting point, how do we define distance from a point, this point right here, to a line, this line right here? We have to remember that one. Distance from a point to a line is, from the point, it's the length of the perpendicular segment to the line. So if that were perpendicular, what type of triangle do we have here?
A right.
A right triangle. So what is the length of this side going to be?
A squared.
It's going to be b sine of a.
Oh yeah, totally.
You were close, Nate.
Why is that? Because if we call this length a, because it's side a, assuming that's a right triangle, because by definition this has to be perpendicular, we would be able to say that the sine of angle A is A over B, meaning A equals B sine of A. Boom. So if that is the length of the side A they give us, that is going to mean that there is only one possible triangle. What happens if the length of side A happens to be less than B sine of A? Like the length of side A only comes down to here. How many triangles are we going to have?
That's a great question.
None. If the length only comes down to here, how is it going to get down to this side to close off the triangle?
It's not.
It's not.
It's
So, if A is less than B sine of A, no triangles. The fun part comes in if the length of side A is longer than this, but shorter than side B. That would mean that side A could extend down like this, or could extend out like that. So if A is bigger than B sine of A, but smaller than side B, that means there could be 2 triangles. The only option left is if side A is bigger than side B, that is going to mean there is only one possible triangle. So let's look at this example. How many triangles are we possibly going to have in this problem? All of our rules that we just went over dealt with B sine of A, which in this case is 32 sine of 62. which is approximately what? It's about 28.3. So we know that B sine of A is less than side A, which is less than side B, which means we are going to have two possible triangles in this problem. So, we have triangle A, B, well no, this is C up here. A, B, C, we know this is 30, we know this is 32, we know this is 62 degrees. Let's solve this triangle. Start by finding the measure of angle B. We know sine of 62 over 30 is the sine of angle B over 32. So what is the measure of angle B? Rounded to the nearest degree, that is 70 degrees. That's 32 sine 62 over 30 equals the sine of B. So the measure of angle B is the inverse sine of this, which rounded to the nearest degree is 70. From there, what is the measure of angle C? Measure of angle C should be 48 degrees. Then you set up another ratio to solve for the length of side C. What is the length of side C? To get side C, we're going to say the sine of 48 over C equals the sine of 62 over 30. So what is the length of side C? The length of side C is 25.2. So this is one triangle. Now how can we have two? Our other triangle is going to look like this. A, C, B. This is 32, this is 30, this is 62 degrees. The nice part is once you've solved the first one, the second one doesn't really require much work. In our second triangle, the measure of angle B is just going to be 180 minus whatever angle B was in the previous problem. So 110 degrees. And just to check that, why this works, what is the sine of 70? Yeah, the sine of 70 is 0.9396926,208, blah, 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 blah. And if you find the sine of 110, it's going to be the same thing, 0.9396926,208, blah, 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 blah. So that is why this is the ambiguous case. This angle right here, when you do inverse sine, could be 70, could be 110. So you just include both. So angle A is the same, 62. This is 110. What's the measure of angle C then? 8. 8 degrees. So in our second triangle, we still need to find the length of side C. And in that one, it's going to be the sine of 8 over C is the sine of 62 over 30. And you need to solve that. Side C is 4.7. So, for your homework, there's going to be an assignment in Math Excel, as well as 4 problems that I posted in my homework. Now, in my homework, I posted the worksheet for Math Excel like usual. In Math Excel, you will not come across problems like this. In the 4 problems I posted in my homework other than the Math Excel, one will be a situation that has 0 possible triangles. One will be a situation that has 2 possible triangles. The other 2 will have only 1 possible triangle.